All right, guys. Matt 6620 here. Let me bring you up on. I've got Blackboard up here, and I want to show you something. There's a data set BSRI, and I uploaded a video on it illustrating factor analysis and principal component analysis, and it was okay. It was probably one of my better videos because it illustrated more appropriately, real life stuff that we run into with statistics. Let me explain that a little bit more to you, what I mean by that. First of all, this whole quantitative measures 1 and 2 course, what was the intent? And I say what was the intent because technically after this video, we are done with the quantitative methods and we're going to move into the test theory component. Now the test theory part is clearly, but it's related to this factor analysis, principal component analysis, in ways that I'll try to teach you in the upcoming weeks. But anyway, backing up a little bit, so far, we started out with a simple t-test, then we went into 2 sample t-tests, pooled and unpooled. We went into ANOVA. We got into factorial designs, Mancova, and now that all the smoke clears, I want to repeat what was my intent of all this. Well, my intent was not to turn you into an expert on any of those. It'd be great if somewhere along the way that actually happened, but again, that wasn't my goal. That wasn't my expectation. My expectation with this quantitative methods was just to introduce you to lots of different types of things that we encounter in education research. Now, for example, if you run into a situation where a Mancova design is appropriate, should you just know right off the bat how to run one of those, how to test the assumptions? Absolutely not. Guys, I don't even know how to do that. I understand Mancova, I understand the assumptions. I can, tell you those things on a dime, but I got to look it up. I got to look up the R code. I got to look up, what, how to do stuff on R. I don't walk around with all this stuff remembered. I have to look it up, and I have a notebook that I keep this stuff in. Secondly, testing the assumptions and things. But anyway, I guess long story short, the point I'm trying to make here is I can't prepare you for everything. When we get into to real life data, you run into things that aren't necessarily presented in these ideal data sets that we get out of these textbooks. So, and there's no way that I can, for example, running a factor analysis. I'm working with 2 doctoral candidates right now, and they're both having problems with some results, some reliability, some Cronbach alpha results. They're both having some difficulties with results from principal component analysis. There's nothing that I could have given them in a class that would have prepared them for that. It's just the fact that they know something about factor analysis. They understand a little bit about principal component analysis. They've seen them run. They see, overall what we're trying to accomplish here. But there's no way I can prepare you for everything, just like they weren't prepared. But in terms of more specifically the master's thesis project, I'm going to be there right with you through 6996, 6997, 6998. I'll be there right there with you. So when we encounter those things, I'll help you. Or well, you may encounter some things that I don't know how to work, and in situations like that, we'll figure it out together. So anyway, I want to end up this PCA factor analysis with one final illustration. It's one of my favorites. I got this this data set directly from Andy Field's book. This guy just cracks me up in terms of teaching statistics. I think he's one of the more clever. If you've got a if you're a little wheezy, you may not want to listen to any of his videos because he gets pretty crazy in some of them. But he's doing a great job in making connections between using statistics and using R and SPSS for the data analysis. The statistics part, I'll tell you right now, after it's all said and done, the statistics part's the easy part. What drove me crazy and made me, or gave me the most frustrations and the most challenges was making the connection between the statistical techniques, such as Mancova, for example, and how we do that on R. And since most of you, well, all of you will use R for your data analysis, that's why we decided to do it this way. So guys, anyway, Andy Field came up with this hypothetical data set. Actually, I think he did give this to about 20, almost 3,000 students, and he shared the results, and that's what I'm going to do with you, is run through the survey responses that he received. And if you look down through here, some of this may be kind of recently, it may seem slightly appropriate, unfortunately. Statistics makes me cry. My friends will think I'm stupid for not being able to cope with R. Standard deviations excite me. I dream that Pearson is attacking me with correlation coefficients. Well, guys, when you go down through these, you can, and this is posted on Blackboard, so feel free to look at those. The thing that I noticed right off the bat here is, hold on, my dog wants out. Imagine that. Darby, your timing is impeccable. All right, sorry about that. Anyway, when I look down through these 23 items that they gave to, again, almost 3,000 students, everything I read down here, and again, let me back up a little bit. These responses are on a Likert scale, so strongly disagree, and so on and so forth. But notice that statistics makes me cry. Strongly agree, to me, indicates a frustration, a strong frustration level. My friends will think I'm stupid for not being able to cope. Strongly agree, strongly frustrating. Let's go down to number 6. I have little experience of computers. Strongly agree, possibly a frustration level. All computers hate me. Strongly agree, frustration level. However, when I come back to number 3, standard deviations excite me. Strongly agree doesn't indicate a frustration. Strongly disagree would. So one of the first things you've got to do when you get a questionnaire or a survey, which believe it or not, many of you will do in your master's thesis. I'll require some of that stuff, just depending on what you're trying to look at. But what you want to do, and one thing I don't like about this survey is I look down through these questions. All of the, I think 20 is funny. I can't sleep for the thoughts of eigenvectors. Let me know if eigenvectors are driving you crazy, and I won't do anything different. I wake up under my duvet thinking I'm trapped under a normal distribution. Well, again, strongly agree would be frustration. So what I think he should have done out of the 23 responses, I think he should have posed these questions, about half of them, let's say maybe 10 and 13, but half of them where they are posed where strongly agree indicates less frustration, and then another maybe half of them, so to speak, strongly agree indicates more frustration. That way you don't get someone that's just it's just really frustrated and just starts checking off stuff, just kind of gets in a pattern. You kind of mix up the way that they're actually having to think about the responses that they provide. So anyway, gang, what we'll need to do here on number 3, and I'll show you the data set in just a second, we will need to change those answers, make our 1s equal to 5 and our 2s equal to 4, and our 3s, of course, will remain the same. So gang, let me show you the data set. It's really cool. Okay, it's sort of cool. Okay, maybe it's not cool at all. But I thought I already had this up. No, I didn't have it up. So let's go into 200 because I like to be able to see these things. I just I like things to be centered. So what I want to do here is I will want to recode my fives as ones and my ones as fives and twos as fours and fours as twos. And threes will be just fine, only for question 3. So what I'll do is I'll need to sort that. So for Mac, I need to go up to Data and come over here to Sort. And it'll ask you, do you want to expand the selection? Well, obviously, you just don't want to sort this this column. You want to expand the entire selection because, for example, this person right here on number 2 line, this is the first subject, and they have response of 4 on question 1, 5 on So we want these responses to remain consistent with that particular subject. So we're going to expand the selection. And I know that probably goes without saying, but give me a break, okay? So let's go in here and let's change all these to fives. While I'm doing this, I'll tell you that I'm on 2 dissertation committees right now and 3 master's theses. And the dissertation committees, the things that are driving my students crazy are exactly what you guys are going to be learning over the next few weeks. Reliability, validity, Cronbach's alpha, internal consistency. So the nature of the course really changes here over the next few days, well, starting next week. And this may take a while because this is an enormous data set. And this runs extremely slow. Oh wow, I'm going to be here forever. Wow, we should have some music. I would stop and redo the video, but I don't want to. I could have done an if then or a replace if that would have probably been best. But then I would have had to figure that out, so... Oh wow, this is insane. Well, one thing about it, we don't have to change the threes. Whoa, there we go. What's really frustrating when you do this and then you... Alright, so hopefully there's a lot of threes. Oh, there are a lot of threes. Good. Cool, 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 cool. Keep going, threes. Awesome. Okay, here we go. So these fours need to be recoded as twos. And again, I hope this is clear why this is going on. So you got your brackets filled out. Hopefully by the time you watch this, actually today is Kentucky's first round game. So I'm going to put this video up. If I ever get these fours changed to twos and ones changed to fives and stuff, put this video up and head somewhere and watch the game. Wow, this is incredibly boring. Sorry, guys. I should have done this beforehand. It's one thing I like about Excel in my office with my PC is this stuff just works quicker. It just doesn't work as fast with the Mac for some reason. My gosh, there's a lot of fours. Actually, I think there's only like 2,700 cases. Now let me, oh, whoa, back up here, Douglas. All right, we'll get these changed to ones. We'll be set. All right. Something I want to let you know, I've another document that I will upload. I'm going to write this up. I don't like the way I wrote up the previous one. That was something I tried to write up on the fly, and it didn't. I don't think it worked well. So I've taken some time and actually written up this problem. And it is something I'll upload on Blackboard probably later today. Well, I wish I could grab my coffee. Maybe we should play some Taylor Swift. What do you think? What about it, Nat? Guys, I just got your all's second attempt exams back. I haven't graded those yet. Okay, finally. Wow. Let's save this and go through all this stuff. All right, cool. I'm glad that's over. I'll tell you what. Let's do. Let's go ahead and bring up R, and let's get this. Entered. I think that's what I called it. Yeah. And you'll see the names of the data here are just question 1, question 2, question 3, and so on and so forth. So there's 23 questions. What you can do to always find the number of variables, you can do length of your data set, whatever you named your data, and it'll tell you how many variables you have. If you do the length of a variable, for example, Q01, it'll tell you the number of cases that you have. So Field gave this survey to 2,571 students, and we're going to analyze the data. Now he analyzed it as well in one of his books. I'm going to add some stuff that I think I want you to be aware of. So anyway, what the goal of this? Okay, well, let me back up a little bit. An important use of factor analysis is to develop surveys, questionnaires, and tests. And if you're trying to develop a survey or questionnaire or a test that's kind of tapping into some underlying construct or some latent variable, something that isn't directly observable, reliability, validity, and principal component analysis is extremely helpful. So the primary goal of this video is to illustrate the process of developing a questionnaire, something that you would be able to use in research. Believe it or not, you just can't come up with something and say, well, here's 10 questions I'm going to ask my students. Let's see where it goes. If you're not going to use that in any statistical analysis and you're just trying to use it from a descriptive component, then everything's fine. But if you're trying to use it where you want to use these responses in future analysis or get your article published, you're going to have to get into PCA, reliability and validity analysis. Okay, guys, I guess we're actually ready to get this party started. I don't know. I guess the first thing I would do is I would be concerned with sample size. And I say concerned, I say that from a general sense. I don't necessarily think sample size is an issue here. Let me tell you why. There's 2 rules of thumb that I think you should put on your radar for sample size. And just go ahead, it's going to be one of those test questions you're going to run into. One rule of thumb says that you need at least 300 cases. Well, we have 2,571 cases, so we're set. The problem with that, in my estimation, is I think the number of cases is directly related to the number of variables. If I have 100,000 variables, then maybe 2,571 isn't enough. So it actually turns out that there is another rule of thumb, another rule. Oh my gosh, my dog is driving me insane. Hold on. When you want to go in and out. All right, my dog needs a doorman. Somebody just stand at the door and let her in and out. Anyway, another rule of thumb is that that you have at least 15 cases in this case it would be our students, per variable. So guys, if you think about it, we have 23 variables, and I would like at least 15 cases per variable. So that says that I need at least 345 cases, and I have 2,571, so life is good on the sample size.